Part I, Foundations, Chapter 1, Understanding Your Encyclopedia Data, written in the style of a comprehensive guidebook. Part I, Foundations, Encyclopedia Data and Looker Studio Basics. Chapter 1, Understanding Your Encyclopedia Data. Before you create a single chart in Looker Studio, you must intimately understand the raw material you are working with. Your data. Encyclopedic data has unique characteristics that differentiate it from standard business data like sales figures. This chapter will guide you through the structure, types, and key metrics of knowledge-based data, equipping you to design effective and insightful dashboards. Common data structures in knowledge bases: hierarchical, relational. Encyclopedia data is rarely just a flat list. Its power lies in the connections between entries. You will typically encounter two primary structures. One, hierarchical, tree-like. This structure represents parent-child relationships. The most classic example is the category system. Example: science, biology, botany, flowering plants, orchidaceae. Implication for Looker Studio: this structure is perfect for drill-down reports. You can create a tree map or a hierarchical filter that allows users to click from a broad category, science, down to a specific subcategory, orchidaceae, to see all related articles. To relational, network. This is a more complex web of connections where any entry can link to any other entry. The most important example is the hyperlink between articles. Example: the article Albert Einstein links to Theory of Relativity, Nobel Prize, Princeton University, and nuclear weapon. Each of those articles links to many others. Implication for Looker Studio: this structure allows you to analyze knowledge networks. You can build reports that show the most central or interconnected articles, using metrics like number of inbound links, or visualize the relationships between topics using scatter plots to find clusters. Most modern encyclopedias use a hybrid of these two structures: data types, articles, categories, contributors, timestamps, media metadata. Your data source will be composed of several entity types, each with its own set of attributes: fields, articles/pages, the core entities fields, article ID, title, content, text, URL, slug, word count, is published, y/n, categories/tags, the organizational labels fields, category ID, category name, parent category ID, contributors/users, the people who create and edit content fields, user ID, username, join date, user role, e.g., admin, editor, timestamps, crucial for understanding the evolution of knowledge fields, creation date, last edit date, last review date, media metadata, information about images, videos, and other files fields, media ID, file name, file type, attached to article ID, file size, alt text logs and interactions, data generated by user activity fields, timestamp, user ID, or IP, article ID. Action, e.g., view, edit, search, identifying key metrics, page views, edit history, cross-references, user engagement metrics. Transform raw data into measurable insights for an encyclopedia. Key performance indicators, KPIs, focus on content health, usage and collaboration. Usage and popularity, page views, the total number of views an article has received. This identifies popular topics. Unique visitors, the number of distinct individuals viewing an article, reducing bot or refresh. Inflation. Content health and completeness, edit history, number of edits, time since last edited. A stagnant article may be outdated. Article length, word count can be a proxy for completeness, though not a perfect one. Link density, number of internal links/word count measures how well integrated an article is within the knowledge base. Editorial activity and collaboration, top contributors, number of edits or articles edited by a user. Revert rate, the percentage of edits that are undone, which can indicate contentious topics or vandalism. Content gaps, orphaned articles, articles with zero inbound links from other internal articles. These are hard for users to discover. Search performance, number of failed searches or popular search terms with no results. This directly reveals what users are looking for but cannot find. Sourcing data, from Wikipedia APIs to internal databases. Where you get your data depends on whether you're analyzing a public wiki or an internal Corporate Knowledge Base 1 Public APIs, e.g., Wikimedia REST API. How you can pull vast amounts of data programmatically. For example, you can get page view statistics, page metadata, or category members. Looker Studio integration. This requires a community connector. You would write a script, e.g., in apps script, to call the API and format the data for Looker Studio, or use a pre-built connector if available. Example query: get the top 50 most viewed articles on Wikipedia for the last week too. Internal databases, e.g., MySQL, PostgreSQL. How your corporate wiki, like Confluence, MediaWiki, or a custom CMS, stores all its data in a database. Looker Studio integration. Use Looker Studio's native MySQL or PostgreSQL connector. You will write SQL queries to extract the relevant tables and fields, e.g., pages, users, revisions, consideration. You may need to create a database view that joins multiple tables to get a clean data set for reporting. 3 intermediate sheets, e.g., Google Sheets. How, for smaller projects or one-off analyses, you can export data from your wiki's admin panel into a CSV and upload it to Google Sheets. Looker Studio integration. This is the simplest method. Use the Google Sheets connector to link directly to your sheet. This is excellent for prototyping before building a direct database connection. Chapter 1 Key takeaway: the time invested in understanding the structure and meaning of your data is the most critical step in the dashboard creation process. It ensures the reports you build in Looker Studio are not just visually appealing, but truly meaningful and actionable. Chapter 2 Getting started with Looker Studio. Following the outline provided. Chapter 2 Getting started with Looker Studio. This chapter serves as your onboarding to the Looker Studio environment. We will move from a high-level understanding of what the tool is to the hands-on process of creating your very first report. By the end of this chapter, you will be comfortable navigating the interface and will have built the foundational shell of your Encyclopedia dashboard. What is Looker Studio? Overview and key features. Looker Studio is a free, cloud-based business intelligence, buy, and data visualization platform from Google. Its primary purpose is to transform raw, often complex, data into interactive, informative, and easily understandable reports and dashboards. Think of it as the bridge between your data, like the encyclopedia tables we discussed in Chapter 1, and your audience, researchers, editors, or the public. It doesn't store data itself but connects to it, pulling in information to create visualizations. Key features that make it ideal for encyclopedia dashboards: free and accessible, anyone with a Google account can use it, making it perfect for public projects, nonprofits, or internal corporate use without licensing fees. Connectivity: it offers native connectors to a vast array of data sources, from Google Sheets and BigQuery to MySQL and Wikipedia APIs, often via community connectors. Drag and drop interface: you don't need to be a programmer to build reports. Adding charts, filters, and text boxes is intuitive and visual. Real-time collaboration: like Google Docs, multiple users can edit a report simultaneously, perfect for teams building a knowledge-based dashboard together. Interactive dashboards: you can create controls that allow users to filter, sort, and drill down into the data. A reader could click on a category in a chart to instantly see all its articles. Sharing and embedding: reports can be easily shared via a link, scheduled for email delivery, or embedded directly into a wiki or website, making your visualizations a living part of your encyclopedia. Setting up your account and navigating the interface. 1 Account setup: navigate to Looker Studio. Google.com. Sign in with your standard Google account, e.g., a Gmail or Google Workspace account. That's it. There is no additional installation or payment required. You are ready to start. 2 Navigating the home screen: create, the prominent button to start a new report. Recent reports: a list of dashboards you've been working on or have viewed. Templates: a gallery of pre-designed report templates you can use to jumpstart your project. Shared with me: reports that other users have given you access to. 3 The report editor interface: once you create or open a report, you'll see a workspace with several key areas. Canvas: the large central area where you design your report. This is your page toolbar, at the top, with buttons for undo/redo, view mode, theme, and share. Menu bar: file, edit, view, insert, format, Arrange, Data, and Help menus components. Left panel contains the tools you add to the Canvas page, a new page in your report, like a new tab, charts, bar charts, line charts, pie charts, tables, etc. Controls, input boxes, drop-down menus, sliders for user interaction, text, for titles, labels, and explanations, shapes and images, for branding and visual design, theming and layout. Right panel. This context-sensitive panel changes based on what you selected. It's where you configure your data, style, and layout settings for any selected chart or component. Core concepts, data sources, reports, pages, and components. Understanding these four terms is crucial to thinking in Looker Studio. 1. Data source. This is not your raw database, it is a connection that you configure within Looker Studio to access your data. It defines which table, which fields, and any initial calculations or filters. You can connect one report to multiple data sources, e.g., one for article metadata and another for page view stats. 2. Report Studio file. This is the entire dashboard file you are building. It contains all your pages, charts, and data source connections. It is saved automatically to your Google Drive. 3. Pages. A single report can have multiple pages. Use this to organize your dashboard. For example, page 1, Executive Summary, page 2, Category Explorer, page 3, Contributor Analysis. 4. Components, visualizations. These are the individual elements you place on a page. Every chart, table, filter, control, and piece of text is a component. They are all customizable and can be linked together through interactions. Creating your first blank report. Let's translate theory into practice. We will create a simple shell for our Encyclopedia dashboard. 1. Initiate creation. On the Looker Studio home page, click the plus Create button and select Report from the drop-down menu. 2. Connect a data source. A pop-up window will appear asking you to choose a data source. For this first step, we will use a placeholder in the search bar. Type Google Sheets. Select it. You will be prompted to select a specific sheet. Since we don't have one ready yet, click Cancel. For now, Looker Studio will create a blank report with no data connected. This is fine for getting familiar with the interface. 3. Explore the workspace. Take a moment to look around. Notice the blank canvas. Explore the Components menu on the left. Hover over the chart icons to see their names. Click on the Theme and Layout panel. On the right, it will show default report level settings like canvas size and background color. 4. Add a title. From the Components menu on the left, drag the text box onto the canvas. Type Encyclopedia Knowledge Dashboard. Use the toolbar and the Style tab in the right panel to make it large and bold. 5. Save your report. Looker Studio saves automatically to your Google Drive. However, you can give it a proper name. Click on Untitled Report in the top left corner and rename it to My First Encyclopedia Dashboard. Congratulations! You have just created your first Looker Studio report. It doesn't have data yet, but it has a foundation. In the next chapter, we will replace our placeholder with a real data connection and begin bringing our encyclopedia to life. Try it yourself. Before moving on, spend 10 minutes experimenting. Add a few different chart types from the menu onto the canvas. Don't worry about how they look, just get a feel for dragging, dropping, and resizing components. Delete them when you're done. This hands-on practice is invaluable. Chapter 3, Connecting to your data, following the provided outline. Chapter 3, Connecting to your data. This chapter is the practical bridge between your raw data and the visualizations you will build. Connecting to your data is the most critical step in the process. A clean, well-structured connection ensures your dashboard is both powerful and performant. We will explore the various methods to bring your encyclopedia data into Looker Studio, from simple spreadsheets to live APIs using built-in connectors. Google Sheets, BigQuery, MySQL. Looker Studio doesn't store your data, it connects to it. Live built-in connectors are the most stable and officially supported way to establish this link. 1. Google Sheets, the perfect prototyping tool. Why use it? It's incredibly easy, requires no IT infrastructure, and is ideal for smaller datasets or for building a proof of concept before moving to a database. You can export data from many systems into a CSV and import it into Sheets. How to connect? In Looker Studio, click Create Report in the Data Source window, select Google Sheets, choose your sheet and the specific worksheet tab containing your data. Click Connect. Best for manual data updates, collaborating on data collection, and initial dashboard prototyping for your Encyclopedia to MySQL/PostgreSQL, connecting to your live wiki database. Why use it? This is the direct source for most corporate or self-hosted wikis, like MediaWiki, Confluence, or custom platforms. It provides live, direct access to your articles, categories, and user tables. How to connect? You will need your database's hostname, IP address, port, database name, username, and password. This info typically comes from your IT department or hosting provider. In the data source window, search for and select the MySQL or PostgreSQL connector. Fill in the connection details. For security, you can use SSH tunneling if required. You will then write a SQL query, e.g., select from wiki_pages. Or choose a specific table to pull into Looker Studio. Best for building production grade, automated dashboards that reflect real-time changes to your knowledge base. 3. BigQuery, for massive, analytic scale datasets. Why use it? If your encyclopedia is as large as Wikipedia or you have extensive user log data, BigQuery is designed for lightning-fast analysis of terabytes of data. How to connect? The process is similar to MySQL. You write a SQL query to define the dataset you want to use. BigQuery's cost-effective pricing model, pay per query, makes this feasible for large-scale public projects. Best for analyzing billions of page views, performing complex joins across massive tables, and historical trend analysis over very long periods. Connecting to public APIs, e.g., Wikimedia API, with community connectors. What if your data isn't in a database or sheet? This is where the power of APIs and community connectors comes in. The challenge: Looker Studio cannot natively call most public APIs. The solution: community connectors. These are pieces of code, often written by third-party developers or Google, that act as translators between an API and Looker Studio. Connecting to the Wikimedia API, example workflow 1. Find a connector. In the data source window, click on Partner Connectors or Community Connectors. Search for Wikipedia or Wikimedia. If one exists, you can use it to build your own. Advanced: if no connector exists, you can build a simple one using Google Apps script. This script would receive a request from Looker Studio, e.g., get page views for data visualization, call the Wikimedia REST API, https://in-wikipedia.org/api/rest_v1/, receive the JSON response and format it into a table-like structure that Looker Studio understands. Send that formatted data back to your report. 3. Authorize and configure. You will typically need to provide any required API keys or parameters, e.g., project name, article title, in the connector's configuration screen. Preparing your data source, ensuring clean and structured data. Garbage in, garbage out. The quality of your dashboard is directly dependent on the quality of your data source. Before you connect, ensure your data is prepared. Use a tabular structure. Data must be in a table format with one header row. The first row should contain unique, descriptive names for your fields, e.g., article_title, page views, edit_count, consistent data in columns. Every row in the edit_count column should be a number. Every row in the timestamp column should be a date. Clean your data, remove blank rows and columns that can confuse the data schema. Check for inconsistencies, ensure categorical data is consistent, e.g., biology, and bio should be standardized to one term. Handle nulls, decide how to represent missing data. Looker Studio can often handle this, but it's best to clean it at the source. Pre-aggregate when possible. If you need a chart showing total page views per article per month, it's more efficient to do that aggregation in your database query, group by article, month, than to force Looker Studio to process millions of raw page view records. Best practices for data refresh and management. How often does your data update? The answer dictates your connection strategy. 1. Understanding refresh types. Live connection, default for DBS/BigQuery. The report always queries the underlying database when viewed. This provides real-time data but can be slower for large queries and puts load on your production database. Extracted data. Looker Studio can create a snapshot copy of your data and store it on its own servers. You can set the refresh interval, e.g., every 15 minutes, every 4 hours, daily. This is faster for report Loading and reduces load on your source system but means the data is not real-time. 2 Best practices: use extraction for performance. For large public-facing dashboards where data only needs to be updated hourly or daily, use extracted data to ensure a fast user experience. Use live connections for accuracy. For internal editorial dashboards where users need to see the very latest edit, a live connection to the database is preferable. Manage credentials securely. Use service accounts or OAuth for database connections instead of personal passwords, especially when sharing reports. This allows you to manage access centrally. Use data source files. Instead of connecting each report directly to your database, create a reusable data source file. You can then connect multiple reports to this single, managed connection. This allows you to edit fields and formulas in one place and have the changes propagate to all reports. Chapter 3 Key takeaway: choosing the right connector and properly preparing your data is the unglamorous but essential foundation of a successful dashboard. A well-built data connection ensures your encyclopedia visualizations are not only insightful but also reliable, performant, and easy to maintain. Chapter 4 The Article Overview Dashboard. Following the provided outline. Part 2 Building Core Encyclopedia Reports. Chapter 4 The Article Overview Dashboard. The Article Overview Dashboard is the executive summary of your knowledge base. It's the first page stakeholders and editors will see, designed to answer the most critical high-level questions at a glance. How big is our encyclopedia? What is it about? How is it growing? What content is most popular? This chapter guides you through building this foundational page. Designing a high-level summary. The goal of this dashboard is clarity and immediacy. Avoid the temptation to cram every metric onto one page. Instead, focus on the 3 to 5 most important KPIs that define the health and scope of your project. A well-designed overview should tell a story in under 30 seconds. Key questions to answer: scale, how many articles do we have? Scope, what are the major topic areas? Velocity, how fast are we growing? Engagement, what content are users reading most? Layout strategy, adopt a top-down information hierarchy. Place the most crucial summary metrics, KPIs, at the top left, where the I naturally starts. Supporting charts that provide context and detail should flow to the right and downward. Key components: total article count KPI, articles by category pie chart. Let's start building. Ensure you have connected a data source containing your article and category data, e.g., a pages table. 1 Total article count KPI, key performance indicator. Purpose: the single most important metric, instantly communicating the scale of the project. How to build: from the Components menu, add a scorecard chart in the Data tab of the right panel. Assign the article ID field, or any unique key, to the metric. Ensure the